This video will explain the syntactic structure of Prolog and how Prolog is as a programming language. To understand that, first we have to remember that Prolog falls under the logical paradigm in programming languages. And this slide shows the syntactic structure of Prolog, which appears to be quite simple, but this also only shows the non-terminals of the language. So in simple words, it is saying that a program consists of predicates. Now, predicates are a collection of clauses, and clauses can be of two types, base clause and non-base clause. The base clause just consists of structure, which basically means function, and functions look different in Prolog. Now, non-base clause consists of an if statement between two functions or more. Now, to understand how Prolog works, we need to understand what are facts, rules, and queries. And to understand that, we need to know what are variables and names. Now, variables and names are distinguished by the fact that variables have to start with an uppercase letter and names have to start with a lowercase letter. So variables are assigned to some value and they stay of that value for the rest of the program, not like Python, how you can change. For example, x is equal to y, and then x is equal to x plus 1, and then you cannot do that in Prolog. It's basically like mathematical variables. Names, we're going to see how they're used in Prolog. Now, a fact is a predicate expression that makes a declarative statement about a problem domain, and this is how facts are used in Prolog. So if we say likes John Susie, this means that John likes Susie. Now, and variables are universally quantified in Prolog, which means that if we say likes X Susie, it means that everyone likes Susie. Now, this notation means or in Prolog. So if we say John likes Susie or John likes Mary, that's what this sentence means. And also facts have to end with a full stop. So if we say likes, not likes John pizza, it means, well, John likes pizza, not, so John does not like pizza. And if we have John likes Susie, if John likes Mary, that's what this means. Okay. So this is how we look at facts, and now rules. Rules basically have a left-hand side and a right-hand side separated by a logical implication, which we just call if. So rules are defined by horn clauses. So horn clauses, this is the definition of it. So it consists of a head, which is left-hand side, and a body on the right-hand side. Now there can be 0 or more heads, so the head is not necessary. But the body can consist of a list of predicates. So it can consist of one or more predicate. The left-hand side, which is like the head, has only one single literal. And the right-hand side can consist of more than one literal. So these are all examples of horn clauses. So this is headless and headed horn clauses. John is a son, and John is Mary's son. John is a boy if John is Mary's son. This is what this means, and this is a headed horn clause because it has a left-hand side. Okay. So now we have to understand what queries are, which are the same as goals, and these are the things that we ask Prolog as the user. So Prolog has like a database which is defined by these facts over here. So Alice likes John and John likes Mary. Now, if we ask Prolog, does Alice like John? This is a question. And the Prolog, the interpreter says true. Now, if we say, does Alice like Mary? Notice that this is not written anywhere in our database. So the interpreter is going to say false. Even though that might be the case, but we ask the questions that we write about the database, and that's what the Prolog interpreter answers. Now, the basic control structures, there is logical and there's two more. So if we start by logical and, it's represented by the comma operator, and it can be between two queries, or it can be between subgoals of clauses. Okay, so let's see what that means. So this is x and y, they're both variables. So x is equal to 1 and y is equal to 2. Now, if it appears between subgoal clauses, why are they called subgoals? Because in this sentence here, there's a left-hand side, there's an if statement or logical implication, and there's a right-hand side. And in the right-hand side, these are subgoal clauses because there's 3 of them. So this is a rule just like we saw in a few slides ago. So now another basic control structure is the cut structure. So basically this means that if you ask Prolog to give you answers, if it has more than one answer, you can ask it to stop after the first one. So if we have here parent A is a parent of B, and A is a parent of C and D. So if we ask A is a parent of X, which is like A is a parent of what? Prolog is going to tell us that A is a parent of B, C, and D, but we can ask Prolog to stop after the first child. So Prolog is going to tell us that A is a parent of X being B, and then it's going to stop. So that's another control structure. Now the other one is disjunction or logical OR. So here we have John is the parent of Bob and Lily is the parent of Bob. Now John is a male and Lily is a female. So father, that means the father is parent and father is male, mother is a parent and female. Now this was an example of and, now this is an example of or. So we're going to say that X is the child of Y if there's a father or if there's a mother. So either one of them makes X the child, if it has a dad or if it has a mom. So now we have building blocks. There's 4 main building blocks in Prolog. Well, there's numbers and there's atoms, which are basically like nouns or names. They begin with a lowercase letter. Then there are variables that are more analogous to mathematical variables. And then there's predicates. Well, they look like functions in other languages. And a simple predicate asserts something, which is like a fact. So it tells you that is mammal a cat. Okay. Now the environments used by the environments that Prolog uses is SWI Prolog, is a comprehensive free Prolog environment. Now the memory model of Prolog, this is the default program execution system, and it has to be supported by every Prolog executing system. And it's basically a list of goals and it's top down. So it starts with the main goal and then it goes through to the left-hand side of the goal. And then it expresses it. It replaces the left-hand side of the goal in the list with the right-hand side of the goal. And then it goes down and expands the right-hand sides of the goal until it reaches the truth that the user is asking. So now we have a chance to look at how Prolog is in action. So here I defined a bunch of just facts. So Mary likes food, Mary likes wine. So now if we ask likes Mary and food and we run it, yeah. This was from before. So Prolog is going to say true. Now, if we say likes Mary foods, and we delete this and we run this, it's false. Okay, because foods is not defined anywhere here. So if we say, then if we go here, here are some examples of things that we can ask. With this little database that we have, a bunch of facts, if we want to ask, was George the first the parent of Charles the first? This is how we can ask it. Parent, Charles 1, George 1. So because here we have a bunch of parent facts and George 1, Sophia. So we have Charles 1, James 1, and we'll see if this fact exists in the database that we have. So we ask the question here, and we have Charles 1, George 1 is false. So this is how Prolog works, and this is a very simple example. These are simple examples of the Prolog model, and it can get very complicated. And I hope you enjoyed this video. And these are the sources that I have used.